So we do, I should go look. Two quick announcements about this particular thing you just wrote down. First, I'm not done grading the test. These are all fake scores. I, uh, I used a random number generator to make these. Because
I thought you were real. You had to put that before. You put that before.
it's 5 minutes in the period. We're fine. You're fine. Anyway, I'm about 3/4 of the way done, let's say. I told you guys how I'm having that giant remodel in my house. The document camera that I used to like scan all of the like grade cam sheets was buried up in a really high box that Mr. Talbot just got down last night. So I haven't done any of that stuff, but I did get through a lot of the FRQs. So, which is the harder part. Anyway, so just so you know, I'm almost done grading, not done grading yet. And these are all fake scores. Those are my two announcements. Okay. Below is the data from the scores of our chapter 1 individual test, fake chapter 1 individual test out of 22 points. Also, I made it out of 30 students. We actually have 31 students in this class, but I just couldn't do it. I made 30 numbers to be a nicer number because anyway, I couldn't do it. Okay. Percentile. This is our new vocab word for today, percentile. The xth percentile is the value with x percent of observations less than or equal to it. And the most important part that you read there is the less than or equal to. So I'm going to come back with my highlighter. If anyone likes to make their notes a certain way. And I'm going to make sure I highlight that less than or equal to. So if you heard me say nothing else in that jumble of fancy words, hear me say less than or equal to. Okay, and then I have 3 bullet points here that are facts about percentiles. This one is a bit of language to make you sound like you're educated. A number is at a percentile, not in a percentile. We don't use the word in, we use the word at. I'm going to give you some really common ones. Q1 is that's my approximate squiggle, by the way, if you're wondering. Q1 is about the 25th percentile. Can you guys tell me what you think the median is? Yeah, so the median is about the 50th percentile. Give me one more. Yep. Okay, and then here's a really common one that we use in education. And I don't know where else you use it. I've seen it used a lot of times in test scores. All of the 10% are deciles. So you're in like the first decile or the second decile. But I never hear that used anywhere but like either psychology tests or education tests, like the SAT and stuff like that. But I don't know. You tell me if you hear it out in the wild on other types of research. Okay, and then the last thing about percentiles. A high percentile is not always good. So you guys will learn this about me, but my son, he loves golf. It's his favorite thing. To have a high percentile of a golf score is really not a great thing because you want those to be low. Does that make sense? Another really good example is like running a race, like race times. Sometimes the lower numbers are better. So you want to be in the lower percentile. Do you guys have any questions about what that is? Any of those things so far? Okay, now I'm gonna move this and let you guys set this part up. And if you're wondering, Mariano and Colleen are over there on the cabinet right above Lydia. You didn't know they took the test, did you? How do you feel about Mariano's score? That's not bad, right? For a chameleon with no hands. How he bubbled in those circles, we'll never know. All right, you guys. So Mariano the chameleon scored an 18.5 on the test. Calculate and interpret Mariano's percentile. In these problems, when I say interpret, I mean like write a second grade conclusion sentence. There's not anything fancy here. You're just going to say your answer in a sentence. So 18.5 percentile is all the observations less than or equal to. So I'm going to count all the way from the bottom up less than or equal to 18.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Notice 22, 23. I'm counting all the way through the 18.5. So it's less than or equal to. Does everybody understand that? Okay. So Okay, any questions about Mariano's percentile? Should he be happy with that? I think so. Okay, Colleen, on the other hand, scored at the 30th percentile. On a test score, that's not great. That's okay. We still love her. It's fine. So we want to find Colleen's score. And what we're going to do is we're going to say the 30th percentile. And we're going to translate that into 30%. So 30th percentile, 30%. And we're going to say, what is 30% of the 30 scores in class? So we took this percent, converted it to a decimal, and then times the total number of observations, which was 30 people in class. And this is what? You guys can do 3 times 3, 9. Okay, that means that Colleen's score was about the 9th score from the bottom, the 9th score in the list. By the way, if you get something that's not perfect, you need to round that number to get the score, because the number of scores is discrete. So you can't like have a 9.3 score. So you're gonna round that number. We don't have to round this because it came out perfect. But if you get like 9.5, make that the 10th score. Okay, so let's count from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. So Colleen scored a 15.5. Okay, any questions so far? Good so far? Okay, now the next thing we're going to do is make a gigantical heinous graph and table. So I highly suggest you take a second, walk and get a straight edge of some type. Oh, I'm sorry. I didn't mean to cover that up. Are you all set, honey? Isabella.
did you guys gotten? Was it? Okay, guys, so we are going to start this drafting table together, and then I'm gonna give you China or Greeks to finish it. It should only take a few minutes. Sorry, I had to get you for a second. I can't like reach the thing to write. So, okay, so a cumulative relative, you're gonna sound really smart. Go home tonight, be like, what you learned? I learned about cumulative relative frequency graphs. You'd be like, oh, you're a genius. What we're gonna do is it's basically a histogram, like we did from chapter 1, except for it adds all of the things together. So what we're gonna do in this column, this is frequency. It's just, I didn't have enough room to write more frequencies or freak. What we're going to do is count how many values there are of the numbers in between these two. So, and just like a histogram, this is 13 to 13.9 repeating. So what I like to say is how many numbers are in the 13s. Okay, flipping back to our data set, there's not any numbers in the 13s, correct? Looking at the very start of the notes. And I did that on purpose to start with one that was 0. This is short for cumulative frequency, which means I'm going to add them together as I go, but the first one is just 0. Cumulative relative frequency means that I'm going to take the cumulative frequency and divide it by the total, but that's still 0 in this particular part. Okay, and this isn't going to make any sense until I get a couple of spots in, but I do want to graph the point. This is going to be 13. I want to graph the point 13, 0 here. Okay. How many numbers were in the 14s? 5. Great. There are 5 numbers in the 14s. Everybody see where I got those from? Okay. And then the cumulative relative frequency means that I add this and this together. 0 plus 5 is still 5. And 5 out of 30.
we're gonna go to the hundredths place in this table just because it's like impossible to graph more accurate than that. So you're gonna go 14, 0.17. Okay, let's do one more row together, and then I'm going to give you a few minutes to finish it in your groups. Okay, how many numbers in our list were in the 15s? 5 again? Okay, so cumulative means I add up all of these. So there's 10. You see where the 10 came from? It's really important. And then I did 10 divided by 30, which is 0.33, and I made a dot at 0.33. Everybody get what to do? Okay, I'm gonna just keep going silently up here. You guys keep working in your groups, talk it out. Try to be not too slow about it though. Definitely you can speak to each other. Okay, I heard an excellent question just now. These are weird. You know how like in math one, I yelled at you because you tried to like connect the dots, and I was like, make a line of best fit, and then you had to like go like, yeah, that's not this. This is like literally just it's gonna be like ziggy zaggy. So like there's not a pattern. I know it's weird. We're so used to modeling mathematics, which is great. Just for funsies, this is the corresponding histogram and box plot for this data. It's got a little bit of a right skew if you take a look at it. And can you tell look at the cumulative, how it flattens out at the top? That you can tell that that's kind of the tail. So a little bit back to chapter 1 there. All right. I have certain people in the crowd who like to make their notes different colors. The next part that I do is going to be in a different color, just in case you want to get a different color out. Okay, so for A and B, these two questions are going to be asked graphically. This is not a calculation that we're going to make based on the data set. It's a calculation we're going to make, an estimate we're going to make based on the graph itself. So get out that straight edge and your different color. And what you want to do is estimate and interpret the 90th percentile. So you're going to take your straight edge to the 90th percentile. Yeah, you see it. Okay. And then follow it over to the graph. And then follow it down to the x-axis. I like this. I don't know why. I think this is fun. And then make an estimate. What do you guys think? Mine came out to be 18.4-ish. What'd you guys get? These are going to be estimates. Notice it said estimate, and we're all not perfect graphers either. And I am not perfect right angler. So I'm going to go with 18.4. Okay. But you can put whatever you got. Okay, and then we're going to estimate the median and IQR using the graph. So the median, I told you guys, was the 50th percentile. So I'll go on up here to the 50th percentile, estimate the median. I don't think I went straight down. I think it should be like 15.8. 15.8, I don't know. Notice I covered myself with my squiggles. Okay, now blast from the past of chapter 1. What do you guys think we're going to do to find the IQR? What percentile would the third quartile be? 75th. Okay, so come up here, find the 75th-ish. What are your thoughts on that? Thinking 17.5? Okay, and what percentile would the first quartile be? 25th. Look at you using that vocab from chapter 1. Nice. Hmm. 14.4. 14.5. What do you think? If we put 14.5, the math's a lot easier. I mean, 3.1 wasn't like rocket surgery, but hey guys, we have one more thing to learn today, and that is Z-score. Which is what was on those two weird problems that I accidentally had in the MCQs, if you remember. Okay, so let me explain Z-score and what it is used for. Z-score is a way to compare stuff that isn't out of the same amount. So like you have one of your friends is in math 3, let's just say, and you come out of your class and you like meet them in the hallway and they come out of Miss Rice's class and they're like, did you take your test? And they're like, yeah, I took my test. And they're like, what did I get? And you're in your you say like an 18.5. And then your friend that's in math 3, I don't know if you guys remember, but those tests were on 40. And your friend comes out and they're like, I got a 37. And then you're like, oh gosh, I must be terrible because I got an 18.5. But your test is out of 22 and their test is out of 40. What would you guys normally do? You find the percents, right? Compare the two. Not that you should be comparing your grade. This is a terrible example, I just realized. How horribly unhealthy is this? Oh well, too late now. We all do it. Anyway, so you would make percents out of the two of them and you compare them. Okay,
Z-score is kind of the stats way of doing that. It's the way of comparing, of using the same language for every single problem. If you guys come back behind Cameron over here, I've purchased myself this giant magnet. And these guys here are Z-scores, these giant numbers. Okay, this is in the middle. So a Z-score of 0 is usually like the average, the test average. And then if it's a good thing, like a test score, these ones would be the higher scores, and these one would be the lower scores. So if you have a negative Z-score, it means you did poorly compared to everyone else, not poorly. And then if you have a higher Z-score, that means that you did better than average. Unless you're talking about golf or running a race or something, then you want to be on the lower end, not the higher end. Does that make sense? Okay, so Z-score is basically like how in stats we talk the same language about things. And you're going to hear it called standardized score, and you're going to hear it called Z-score. Both of them are, we're going to use those interchangeably, unfortunately for you. Okay. Okay, let me read my Mrs. Talbot font to you there. I don't know, my handwriting's like half cursive, half regular, and any numbers that are in my name or any letters that are in my name are like weird. So a Z-score tells you how many standard deviations away from the mean your value falls and in what direction. And there's actually a formula for it. Z equals X minus the mean divided by standard deviation. Okay, these are Greek letters. I'm just going to let you get all of your laughs out now, ready to go. Here you go, mentally prepare. This is the letter Z. This is the letter X. This is lowercase mu. This is lowercase sigma. There you go. Ha, 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 ha. Now, if you have a sample, it's a little different. You're using sample mean, which is X bar, and sample standard deviation, which is S of X. These two are exactly the same formula, but this one is for the whole population. This one is for the sample. Okay, so the last thing we're going to do is find Mariano and Colleen's Z-scores. I got to flip the page over. And then we're done. If you're at the bottom of your page, you might want to flip over, not your whole body, just your notebook. Okay.
This is the end, by the way. Okay, now because I wanted to save you time and money on your car insurance, not really, just time, I put all of the numbers into L1 and calculated the mean and standard deviation of our fake test scores that we're using for this lesson. And so we're going to use these for calculating Mariano's Z-score. You guys know how to find these, right? Let's just take 1 second. You would have gone back to the top of the notes where all those numbers were, entered them into L1, gone stat, calc, one variable stats, and I just stole these out of there because I was too lazy to do any of the actual work. And that will be my expectation from here on out. I will not expect any of that stuff to be done by hand. It'll all be calculated. Okay, so calculate Mariano's Z-score and interpret. He got an 18.5. Okay, so Z equals. You want to take the value that you're interested in first. So that's X minus the mean, which is 16.8, which I got from the calculator, divided by standard deviation. And make sure that when you put this in the calculator, you either use parentheses or hit enter. I do this in 2 steps. I'm going to do the top and then hit enter. Zero 0.9234. Okay, so there's your interpretation. Mariana's score is 0.9234 standard deviations above, and it's above because it's a positive number, the mean of 16.8 points. Okay, so back here, if this was normally distributed set, which I don't know if it is or not, I didn't check, but 1 is right here, so Mariana would have scored like right about there, which is pretty good. I think Mariana should be happy. Okay, last problem of the day. If Arthur had a Z-score, Arthur, by the way, is this compound here. His name is Arthur. I just stole a different Squishmallow for the last example. If Arthur had a Z-score of negative 0.474, what score did he get on the test? Okay, so the Z-score is this. And what you're looking for is to find his score, which means that there's going to be algebra. Oh no. Math in math class? Weird. Okay, what's the order of operations here? What should I undo first? Multiply both sides. And then add 16.8. Okay, so this is close enough. What score did Arthur get? 15.9 is really close to 16. Okay, now last thing I want to say, and I want to make sure this is in the video. That's done. We're all done. But those notes is this right here. So tomorrow I'm going to stamp this box because you completed those notes. Does that make sense? Okay, the homework is 1 through 19 odd. Do you know where to find that? No. Okay, so what you're going to do is go to your Clever. Hold on, this is not what I wanted. This is not at all what I wanted. Hold on. Okay, you guys, real quick, it's right here. It's the squiggly lines in Clever called Achieve. I just need 1 second. But I do want to tell you something real quick. This is super important. The ebook is on the left side. You saw that on the first day of school. However, it's really important that you notice something. I swear to you, it's important. Chapter 2 is still in Unit 1. So if you go to the drop-down menu over here, don't go to Unit 2. Unit 2 has chapter 3 in it. You have to look at Unit 1 has chapter 1 and 2. Does that make sense? Okay. I accidentally clicked on Unit 2 thinking because we're in chapter 2. No. Okay. Where'd she go? There you go. Where's this?